Welcome to Math with Mrs. Bibb. Today we're going to discuss the quadratic formula and what the discriminant means within the quadratic formula and why it's important to know the discriminant. This is one of my favorite lessons to teach because I offer students extra credit to sing the quadratic formula to the tune of Pop Goes the Weasel. So here is the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So at some point I'll let you know when you can sing that tune to me. And it doesn't have to be very good because I know that mine isn't top-notch, very good, but it's sufficient and you could understand the tune. So anyway, I will make that post and give you a time frame to come in and sing that for me, and you can earn yourself 5 points extra credit on an assessment. Okay, discriminant. Ax squared plus bx plus c equals 0, where a, b, and c are rational numbers and a cannot equal 0. So, when you do the discriminant, first of all, I'm going to highlight the discriminant is the value under the square root. It does not include the square root. So I'm going to write down here that my discriminant is b squared minus 4ac. If you say the discriminant is the square root of b squared minus 4ac, that's wrong. It is just the value under the radical. Value under the radical. It tells you some valuable information about what your solutions actually look like. So, looking at this first. Oh, I want to write in another color. Looking at, oh, I don't like that, so sorry. At b squared minus 4ac is greater than 0, and it is a perfect square. So if it's greater than 0 and a perfect square, then that means you will have two real rational roots. R stands for real, Q stands for rational, I will stand for irrational, and C will stand for complex, which means you'll have an I, imaginary. Imaginary. Well, most of the time you'll have an I. 3 is a complex number because it would be 3 plus 0i. Okay, anyway. Two real rational roots, and the graph will look like this, or it could be upside down. And for the next one, I'm going to try to draw a straight line. For the next one, b squared minus 4ac is greater than 0, but is not a perfect square. That means you'll have two real irrational roots. And the graph is going to pretty much look the same, except your rational roots are going to be terminating decimals, integers. It's going to be something that comes out as a terminating decimal. It could be a repeating decimal. That happens. Those are rational. Irrational means that the square root of 2 is irrational. It does not terminate. It does not stop. So the graph could look the same. It just depends on where these intersections are. That just depends on that. Okay. And the next one, when it's equal to 0, then you're going to have one real rational root. And that graph is going to look like this. It's just going to touch the x-axis. Just touch it at one point. And then the last one, b squared minus 4ac is less than 0, then that means you're going to have two complex answers, which means this is what your graph looks like. The graph does not touch or cross the x-axis at all. That's two complex answers. It does not touch or cross the x-axis at all. The number and type of roots. So when it's saying describe the number and type of roots, that's here. 2 real rational, 2 real irrational, 1 real rational, 2 complex. So depending on the value of your discriminant, it will decide what we'll put here. We're going to, in example 1, find the discriminant and describe the number and type of roots. Let me go back for one moment. Now, for number 1, it says make sure your equation equals 0. So I am going to add 7, 2x squared minus 10x plus 7 equals 0. When you're doing the quadratic formula or finding the value of the discriminant, it does not matter if your a value is 1. A can be any number with the quadratic formula. Okay, so a is 2 here, b is negative 10, c is 7. The discriminant is b squared minus 4ac. B squared minus 4 times a times c. Let's do the exponent first. 100 minus 4 times 2 times 7. You can go ahead and multiply that if you want to. 100 minus 56. So that means 44 is my discriminant. That's the value of the discriminant. Then 44. 44 is greater than 0. 44 is not a perfect square. So if you look in your chart, I won't go back, but you can look in your chart. Greater than 0 and not a perfect square is 2 real irrational roots. So that would be the answer to example 1, the first one. Your discriminant value is 44, and the number and type of roots you have 2, and they're real and irrational. Okay, for the next one, the second example for example 1. I'm going to make sure it equals 0, and it does. A is negative 5. I like A to be positive, but that's okay. B is 10, and C is negative 15. I am going to do b squared minus 4ac. So 10 squared minus 4 times negative 5 times negative 15. 100, a negative times a negative times a negative is a negative 20 times 15. 0, is that 300? Yes. So 100 minus 300 is negative 200. So this number is less than 0. So that means I'm going to have 2 complex answers. So these answers will have I in it. And then moving on to the last one, I have all my terms on the right side. I'm going to name A, B, and C. And then I'm going to do b squared minus 4ac. So 8 squared minus 4 times 1 times 5. So 64 minus 20. And ironically, I get 44 again. And so that is 2 real irrational. That's the answer to the third one on example 1. Now for example 2, we are going to solve using the quadratic formula. Express your answers in 2 ways, with a simplified radical if applicable, and 2 as a decimal rounded to the nearest hundredth. Don't forget it has to equal 0. My first one does equal 0. And I'm going to tell you what I do when I'm solving using the quadratic formula is I find the discriminant first. It makes it less messy. It helps me know the direction I'm going. It helps me know if I'm going to have a radical in my answer. That's when you have 2 real rational. Or not have a radical. Oops, I said that flipped. It helps me to know if I'm going to have a radical. That's when you have 2 real irrational solutions. Or when I'm not going to have a radical, I'll have a perfect square, and that will make me have two real rational solutions. Helps me to know if I'm going to have an I, which means that that discriminant value is less than 0. It helps me know if I'm only going to have one solution when the discriminant equals 0. So it tells me so much stuff. I like to do the discriminant first. You do not have to, but I like to do the discriminant first. So you will always see me find b squared minus 4ac first. So I'm setting it up to do that. I'm going to do 4 squared minus 4 times 1 times negative 17. So 16 plus 68, is that right? 4 times 7 is 28. Yes, 68. And that is 14, 6, 7, 84. Okay, so this number is greater than 0 and not a perfect square. So now I'm going to have two real irrational answers, and I am going to have a radical in my answer because 84 is not a perfect square. So I'm going to write the quadratic formula and sing it. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And let's fill it in. X equals negative 4 plus or minus the square root of b squared minus 4ac, which is 84, all over 2a, and a is 1. Okay, I'm going to think about 84 just for a minute because 84 has a perfect square in it. Let me think about factors. 1 times 84, 2 times 42, 4 times 21. Well, I skipped 3. 3 times 28. Is that right? Yes. 7 times 12. So perfect squares, I've got 1 and I've got 4. So x is going to equal negative 4 plus or minus the square root of 4 times the square root of 21 all over 2. So it's going to equal negative 4 plus or minus 2 times the square root of 21 over 2. And then I do have a fraction. So I must check to make sure that my fraction can't be reduced. Let me highlight. Do negative 4, 2, and 2 have a common factor? Yes, they do. Each of these are divisible by 2. So I'm going to divide them all by 2, and that will be my final answer. X will equal negative 4 divided by 2 is negative 2, plus or minus 2 divided by 2 is 1, the square root of 21 over 1. So that's my first answer. Exact answers with the simplified radical. So first, negative 2 plus or minus the square root of 21. That's my first answer. That radical is simplified. Now my second answer, I'm going to use a calculator. Negative 2 plus the square root of 21 and negative 2 minus the square root of 21. Okay, I'm going to grab my calculator. I'm going to type in negative 2 plus the square root of 21. Oops. And that gives me 2.5825. And I said round to the nearest hundredth. So let me write that out. You do not have to, you can write the final answer, but I want to write this for you. 2.5825. So rounding to the nearest hundredth is this point, and that tells me to stay the same. So my first answer is 2.58. And then my second one, let me go type that one in. Negative 6.5825. So I have negative 6.5825. And this is in the hundredths place. That tells me to stay the same. So I have negative 6.58. Those are my two decimals. And then my exact answers. So this is the first way to write your answer. This is the second way to write your answer. And we'll just follow the instructions, whatever the textbook says. If it says to write it with the radical and simplest form, then we'll write it that way, and we won't put decimals, but if we're doing a real world problem, we will need those decimals. Okay, let's go to example 2, and it says it must equal 0. So I'm going to add 5, I think I will. I'm going to add 5x squared and add 11. So I'll have 5x squared plus 8x plus 11 equals 0. A is 5, B is 8, C is 11. So I'm going to do the discriminant. B squared minus 4 times A times C. 8 squared minus 4 times 5 times 11. So 64 minus 20 times 11. 220. So 64 minus 220 is negative 156. Okay, so that means I'm going to have 2 complex answers. Okay, so x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Let's fill it in. X equals negative b plus or minus the square root of b squared minus 4ac, which is negative 156, all over 2 times a. Okay, we'll go up here. So x equals negative 8 plus or minus 156 divided by 2 is 78. So 1 times 156, 2 times 78. 156 divided by 3 is 3 times 52. 156 divided by 4 is 4 times 39. So that's going to be my biggest perfect square. I'm going to move this down. Okay, so x is going to equal negative 8 plus or minus the square root of 4 times the square root of 39. Oh, and I think I forgot my negative, yes. So times the square root of negative 1. So x all over 10. So x will equal negative 8 plus or minus 2 times the square root of 39 times I all over 10. I'm going to make that x equals negative 8 plus or minus 2i square root of 39 over 10. Then do these 3 numbers have a common factor? Yes, they do. They're all divisible by 2. So I'm going to divide them by 2. So x will equal negative 4 plus or minus 2i square root of 39. Oops, I goofed that up. 2 divided by 2 is 1. So 1i square root of 39 all over 5. And this is my final answer. When you have an I, you cannot put it into a decimal form. So I am going to just stop there and say that is my answer. Negative 4 plus or minus I times the square root of 39 all over 5. Last question. Example 3. At the World Championship Pumpkin Chunkin Contest, pumpkins are launched hundreds of yards. The path of a pumpkin can be modeled by h equals negative 16t squared plus 124 and 4/10 t plus 42, where h is the height in feet and t is the number of seconds after launch. Find how long it takes the pumpkin to hit the ground. So I want you to think about, just for a minute, if you're launching a pumpkin, how long does it take it to hit the ground? Okay, so our h is the height in feet above the ground. Doesn't say that, but that's what it is. So when it hits the ground, how far above the ground is the pumpkin? Well, it's 0 feet above the ground. So that means in place of my h, I'm going to substitute 0. 0 equals negative 16t squared plus 124.4t plus 42. And if you recall, then we are finding the x-intercepts when we do this. Now we're going to end up with two answers. We'll talk about that once we get there. We're going to end up with two answers to this problem. So let's solve. We're going to use the quadratic formula. I'm going to find my discriminant first. A is negative 16, B is 124.4, and C is 42. So b squared minus 4 times a times c. 124.4 squared minus 4 times negative 16 times 42. So I'm going to get 15,475. Don't ever round until the end. 15,475.36. And then I'm going to get plus because a negative times a negative is a positive. So plus 62. I'm going to add those together. 15,475 and 36 hundredths plus 62 is 15,537 and 36 hundredths. So that is my discriminant. And I'm pretty certain that that is not a perfect square. It is not. And I am going to do the quadratic formula. It's usually x equals, but in this case it's t equals because that's where x would be. T equals negative b plus or minus the square root of 15,537.36 all over 2 times a. So t is going to equal negative 124.4 plus or minus the square root of 15,537 and 36 hundredths is 124.649. I'll go around to two decimal places in just a minute. 0.649. Now I'm going to get two answers. I'm going to get t equals negative 124.4 minus 124.649, which is going to give me 249 probably. 124.4 minus 124.649. It's going to give me negative 249.05. Negative 249.05, which cannot be the answer because that means time is negative. So I'll throw that one out. And then the other answer is negative 124.04 plus 124.649. So I'm going to add those together. And that gives me 0.609. 0.609. So that's my time. And I'm actually doing time in seconds. So it's going to take 61 hundredths. Let's round to the nearest hundredth. It's going to take 61 hundredths of a second for that pumpkin to hit the ground. So I'm going to write that answer. I'll write it over here. It will take 61 hundredths of a second for the pumpkin to hit the ground. All right, that's it. Hope you have a wonderful day.